thanks for coming, everybody. I appreciate it. I hope you're having a good conference. Before we get into the presentation, I'd like to ask, does anybody know how much a polar bear weighs? Same as yesterday. Enough to break the ice. I'm Taylor. So I work for Dropbox. Do you like my fake t-shirt here? But I just started there about a week ago, so my old employer's t-shirt in that picture. But yeah, so just started there about a week ago. If anyone is looking for work, we have an office in London. Yep, really nice, really cool place. But we're here today to talk about building an OAuth flow in a Node CLI. And I chose to speak about this topic because before having to go through that, I had a really hard time understanding OAuth and understanding an OAuth flow. And by building it in kind of this unique use case, it really helped me understand how to build an OAuth flow, what the components are a little bit better. So I'm on Twitter here at the bottom. Feel free to add me. I'm happy to answer any questions or anything like that later. Or if you want to see some of the samples that aren't going to be published, I'm happy to get those to you as well. So I'm going to give you a chance to leave before we get started by telling you what I'm going to talk about. And if it is not of interest to you, you can leave without offending me, I promise. But we're going to talk about what OAuth is, kind of conceptually, and what it's used for. We're going to talk about using a three-legged OAuth flow, which is what we're going to be implementing together. And then I've got a couple different sample implementations for us to kind of go through together, and we can play around and explore what those look like if you guys are interested in that. But that's what we're going to be talking about today. And if you want to leave, won't be offended. All right. Well, let's get started then. So I am from Washington. Sorry, my intro's longer. Let's actually wait to get started until I do a longer intro. So I'm from Washington, for the United States. More specifically, I'm from Seattle, which is up on the West Coast, and it's a really cool city to live in. We are known for coffee. Starbucks is based out of there. We are known for music. There's a lot of bands that come from there, like Nirvana, and we're also known for a lack of sunshine, which I believe you guys are a little familiar with. And we have a lot of tech companies. Microsoft is out there, Amazon, Google has offices, Facebook has offices, and there's a really big startup culture. So there's a whole lot of tech that's going on. It's kind of a smaller San Francisco, but lots better. So before we get into kind of the technical stuff, I'd like to take a moment to remind ourselves remind us not to take ourselves too seriously. It's my daughter playing hide and seek. Don't know if she's winning or losing. Okay. So we're going to be talking about this topic today because of the API economy. Now, it'd be nice if I had a sweet graphic here with lots of interconnected webs of stuff, but hopefully the API economy itself, the words are enough to kind of conjure up in your mind what I mean by that. There's a whole wide range of tools that are available out there, API-based tooling, that perform all different manner of tasks and functions that you can tap into to bring into your application. And typically, most modern web applications are leveraging data from lots and lots of other different tools. They're bringing it into that core application to allow you to interact with it, read it, write it, do lots of different stuff with it. So if you're building an application today, here's our theoretical app. You may need data from those other applications in order to create that experience for your user. You may need to pull in, these are just some examples here. I don't know what our app does. This seems like a lot to ask for, but you may need to pull in data from your bank info, and you may want info from your bank, but you don't want sensitive information. You may just need to know balances or history or something like that. We may need to pull in social info from Facebook or Twitter. We may want to link it to our chat client, or perhaps we have data in our file storage, which we're trying to suck in. So there exists this need for our application to interact with all this different data. But we don't want to do that, or pardon me. But what if I told you that we could do that without the need to exchange any sensitive information at all? We could just exchange the data safely. Whoa. And that's called OAuth. Actually, pardon me, getting ahead of myself here. Who has seen one of these in the course of using the internet? Yes, most of you. Okay, I also know who's paying attention now, because all of you have seen these, because they're everywhere. Because if you're using the internet anywhere, you're having to link accounts in some capacity somewhere. And this is a screen that you see as a result of an OAuth implementation. Now, OAuth 2.0 is the industry standard protocol for authorization. And more specifically, it is a framework for creating delegated access for data between your applications. And what it does is it allows these applications to communicate, and it decouples authentication from authorization. So instead of authorizing somewhere, you're delegating access to an application to interact with certain types of data. But it's a really powerful protocol because it enables a lot of different use cases. And you are probably using OAuth flows on a lot of different things that you didn't even necessarily know that you were. So web applications use this. Mobile and native applications use this. IoT devices, things that don't even have web browsers, use this. And server-to-server applications, a whole wide range of use cases that this meets. Now, one of the important distinctions that we need to make here is that this is an authorization protocol, not an authentication protocol. Does anybody have an idea what some of the differences there might be? You can just shout them out. When you think of authentication, what is that? What do you typically do to authenticate with an application? What do you need? Yes. So you need a username and you need a password. And we specifically want to avoid that. We don't want any sensitive information that's going across the wire. There are some kind of far-flung use cases where you do that, but in general, we're just delegating that authorization. We don't want to use authentication at all. So if you typically will not hear authentication mentioned in the context of OAuth 2 and OAuth Flows, with a couple kind of gotchas here and there. So the OAuth 2 spec outlines a couple of different things within it. There's some different pieces of information that we need to know in order to build one. We need to know about scopes and user consent. We need to know which actors are defined in the protocol. We need to know which clients are being used. We need to understand what tokens are. We need to understand the responsibilities of the authorization server and kind of what different flows are possible. And now, I know it sounds like a lot, but at its core, it's not that tricky once you've done it a couple times. There's some different fundamental pieces that you need to understand, but you don't need to know about all the different flows that are possible in order to implement it for your own web application. So you may recognize this from earlier. This is a consent screen from Fitbit. So if I was trying to link my application to Fitbit, I would come here, and this is what I would see. And what you see at the top and what you see on the side over here are scopes. That's actually where the user is picking and choosing which permissions, which levels of access that he wants his application to have to Fitbit. For Fitbit, the data that he wants Fitbit to expose to his application. And what this also does is it decouples authorization policy from enforcement of that policy, which is also really, really powerful. So that's, the scopes are over here on the side. And not all OAuth flows are set up this way. This one is nice because it allows you to actually check which boxes of which data you want to give your application permission for. In the past, when I've implemented OAuth flows, I had to do that programmatically. And one of the samples we're going to be looking at today, we're actually not doing that at all. So it really differs in how it's implemented. But what scopes do is they allow you to set specific bundles of permissions on certain areas of your data. So depending on how the application is structured, that can be really powerful. You may only want certain types of users to have certain types of applications, or to have access to certain kinds of data. But once those are checked, and once a user clicks allow, we have then captured that user's consent. They have then said it's okay for this user to have access to this particular data that you specified with scopes. Some of the different actors involved are the resource owner. Now that is the person who's using your application. Your application is here in the middle, that's the client. And that user is then delegating access to the client. The client obtains a token from an authorization server. Note this very important hat up here. We can tell it's an official server. And then we're going to use that token to interact with the resource server, which is where the data that we want to interact with lives. Tokens are going to be used as part of our OAuth flow because that's what's actually going to give us access to those protected resources in that resource server. Now, we're going to be using an access token to access those resources. You've probably heard of access tokens before. That's what you pass back to pull data out of an API. And a refresh token is an optional token, and those will typically come back if your access token is short-lived. If it will expire after a certain period of time, some of the ones that I've seen in the past are good for 7 days. Some of them don't expire at all. But if they do expire, you'll get a refresh token, and that refresh token is long-lived. So it will continue to persist, and once your access token expires, you can just use that refresh token to kind of sidestep the need for a whole other OAuth flow. So you'll just store that in a database, and then if a user goes to interact with your application again and it's been a while, then you can just use that to refresh and get a new access token. We need an authorization server. That's over here on the right, and typically we'll have different endpoints for different things. When we're trying to get the user's consent, we'll send a request to that authorize endpoint, and then it's going to give us an authorization grant. Once we have that authorization grant, we'll have an authorization code that gets passed back, and then we'll use that code to make a request to the token endpoint, which will then issue our access token. So it's kind of getting a lot of details here, getting a little bit in the weeds. I'm going to try and keep it a little bit higher level so that we're able to kind of conceptually think about it and understand what the different pieces are before we step into some of the implementation details. But there's a number of different flows that are possible and that meet a pretty wide variety of use cases. We don't have to concern ourselves with them. You just have to know that they do exist. And depending on what you need authorization for and what the constraints are about the tools that you're using, you may need to bring one of these in. For example, if you're using a legacy desktop application that only has usernames and passwords, then you may need to use a different OAuth flow than the one that we're going to be talking about today. We're going to be talking about this three-legged OAuth flow, the one that uses the authorization code. This is the most secure, and this is typically what you'll see most commonly implemented on public APIs, at least most modern ones. And the reason that it's most secure is because the access token that is generated that allows your application to interact with that protected data never touches the front end, never goes through your user agent. So it just stays on the back end of the server. So that is why it's more secure. So the three-legged OAuth flow uses the front channel to get an authorization code. And that is when your user says, I want to access this. Here's a consent form. Once they click authorize, that authorization code gets sent back to your server. Once it has that, then it kicks off a back channel flow where your authorization code is used to then obtain your access token. And that access token is what you're going to use to interact with that data. But as I mentioned earlier, this is the most secure flow, and it does assume that the resource owner and the client are on separate devices. So here's what's happening at a high level. One of the things that always kind of tripped me up about this concept was that it's called this three-legged OAuth flow, but every tutorial or anything I ever read had like 12 different steps that were all doing different things, so I didn't really know what the legs were. So here are the legs. Our first one is getting that authorization grant, is having that resource owner kick off our OAuth flow, and then in consent to our applications interacting. The second leg, once we have that authorization code, is to use it to request an access token from that authorization server. Once we have our access token, the third leg is using that access token to then interact with the resources that are protected in the server, the data that we're trying to get at. So those are the three legs. We have 1, 2, 3, access code, access token, then using the access token to get your data. So again, we're going to try and keep it high level before we dive into the details a little bit more. So the first leg is when we're requesting authorization. So here we're going to get in a little bit deeper into kind of each of the steps. So pretend that this URL up here is one giant long string. Obviously, that's too long to fit on the screen, so I've truncated it at each time there's a new parameter in the code. So first we send a GET request back to that authorization server, and we need to pass back a number of different parameters with that. Up here you'll see response type equals code. That's required of all OAuth flows, and it's just saying what we expect the response back as. You'll typically pass back some identifying information about your application, and that has been set up with whoever. I rearranged my slides a little bit, so it's a little out of order. But when you are trying to create an application to set up these OAuth flows, you will need to register your application with that service. You'll need to go to Twitter, to whatever one it is, and you need to set up your application so that you'll have a client ID and a client secret. Because that's how that service is able to identify your specific application. So that's what's getting passed in as this second parameter up here, this client ID. And that's what's telling them, hey, this is my application that I'm trying to grant authorization to. You'll pass back a redirect URL. And that is how the authorization server knows where to send that authorization code. State, down here at the bottom, is an arbitrary string. It is almost always optional. And what it's typically used for is either an additional layer of security where you're generating some state and then verifying that that state comes back with the authorization code so that you know you're getting the code from the place that you're trying to get authorization from. Or you can also use it to add some logic into your OAuth flow if you want certain users' authorizations to behave in different ways. Maybe they're going to different admin panels or something like that. One of the parameters that is missing up here that we talked about earlier that would also come here when we request that initial authorization code is scopes. And that would just be another parameter that would just be another query string parameter that's getting passed back with our GET request. And it will be set to whatever the access scopes are set on the back end. But it's just an additional parameter. So that authorization server is going to get our request, see all the parameters in it, and then it's going to send a response to that callback URL that we just sent back. And that's going to contain an access code as well as your state. And that's where you have some ability to use that state to perform some custom logic or an additional layer of security, which is typically a pretty good idea if you're creating an OAuth flow for production. You basically want to code additional layers of security into your application to verify that the data is being sent from where you expect it to be sent from, that the authorization code is coming where you're expecting it to come from. But that's the response we get back. So we get back this really long string here, which has our authorization code. Once we have that, we're going to use it in order to get an access token. So we send back another GET request. And you'll note this time we're sending it to a different endpoint. This is going to our token endpoint rather than our authorization endpoint. But we're going to pass back the authorization code that we just got. We also need to tell it what grant type we have, which is authorization code. Again, we need to give it a redirect URL. Say this is where we want you to send the access token. And we're passing back some additional information, such as client ID and client secret. Now, these fields are typically required in an OAuth flow in order for the access token to be generated. There can be some additional logic within there. It's not super common, but at the employer that I worked at before Dropbox, a company called Smartsheet, their OAuth implementation had an extra layer here where the parameters that were getting passed back to request that access token was actually a hash of your client secret and then the access code that you just got. So it was a little bit tricky because there was some custom logic in there. And while that did add an additional layer of security, it also made it so that certain automated tools that would typically connect and go through an automated OAuth flow couldn't make it past that because it was a non-standard implementation. Oops. But once we send that back and we have all of this information, so we have our authorization code saying yes, our user has said it's okay, and we're passing back our client ID and our client secret saying, and this is our application. We have everything we need for the authorization server to then issue an access token. So this is a response that we get. Now here we're using a Dropbox access token. So we have our access token as well as some other information, what account it's associated with, that type of thing. You'll note that there is not a refresh token, this is where it would be once it came back. You would get your access token as well as your refresh token at the same time. And that is because the access tokens are long-lived. That is going to change quite soon. So if any of you are intending to build on the Dropbox API, know that change is coming soon. Along with that, there will be some other changes just with permissions in general. But that is how it is implemented right now. And we have this access token now. We have this code that proves that we're allowed to access the data that's in this protected server. So we can use that to then call out to the API. So here's a simple curl command. And we are going to keep our fingers crossed that it works. If I can remember how to use a keyboard. Oops. Well, that's not going to work. Okay. There. Awesome. So very simple call just to get account info. And all we did is send a curl request back, and we passed back a header which contained our access token. And it's called a bearer token when you send it back like that. But that's a pretty simple way to be able to interact with your with an API, is just with these curl commands. And depending on what you're trying to do, it can be pretty useful. But that access token with the bearer token is always going to get passed back in the header. Awesome. So we have now generated an access token that we can use to interact with a third-party API. But we want to take it one step further. We want to figure out how we're going to actually do that from within a CLI. A little bit harder. We don't have a long-lived server where our code is running that we can just listen for that request coming in and collect the data we need. We need to kind of think through what is the flow of our application. What steps is the OAuth flow going to go through? At which point do we need to have a server available to listen and grab the query parameters? So it gets a little bit tricky. So for those of you that don't know what a CLI is, I hope that all of you do. Hopefully everyone here has used Git or something similar. It is just another way of interacting with your computer. Instead of using a graphical user interface where you're interacting with someone something through your mouse, you're just using the command line, your terminal, your bash, whatever it is, and you're just writing direct commands to tell the computer what to do. And so that's what we're going to be talking about. There's a number of different frameworks that are available to build a CLI in Node. Some of the really popular ones are Oakcliff, Vorpal, Commander, which is what I've used. Now, they're all opinionated. They all have different ways of doing things, of structuring things, of passing back parameters. So I encourage you to look at many of them before you pick one, because there may be a particular style or a particular way of doing things that really resonates with you, or it makes it easier for you to build your application. As I said, I've used Commander in the past to create this Smartsheet CLI. If you're interested in digging into an implementation that's a little bit more robust than the demo that we're going to be discussing today, it's open source. You're welcome to look at it, pull it down, see how it works. When I was working on it, we were doing like a hack week with a team of 8. And some things I liked about it was that it was very easy to split up work that was being done and then kind of stitch everything back together because of how the app is designed. Some things I didn't like about it was once you started passing back very many parameters and trying to modify your calls, it started getting a little bit messy. And the way that it parsed parameters just was hard to kind of understand and deal with. But that's what I used. So for the demo that we're going to be doing today, though, we're not going to be using any of these CLI frameworks. We're going to be using a native Node module that's just called Readline. That's just going to fire up a shell, which will read our inputs and our outputs, and use that to trigger some code that we have in our application. And I intentionally did not pick a CLI because I want you to pick your own if you are going to be building a CLI in the future. But we're going to be looking at a Readline implementation. So it's actually a little small over on the right. But basically, we're using this module called Readline. And so the first thing we need to do is Readline create interface, tell it what our inputs and our outputs are. You can put whatever prompt you want in there, and that's how you'll know that the shell is activated and it's ready for your command. And you fire it up with this readline.prompt down here at the bottom. This is actually all part of the same code. I just had to break it up because it was long. Contrast is a bit poor on the right side, but what you're looking at is a commands array, which has, actually it's not an array, it's an object. It's a dictionary which has a number of different commands that are defined in there. And then I'm just looping through those commands, and I'm just looping through that dictionary and matching it to what gets passed in to then execute that code. So when my shell is fired up, I can say close, list, delete, give it these very simple commands, and know that it will execute that code. So this type of implementation can be useful just for testing and trying to get your logic correct before you move it into a CLI that may be a little bit more complicated to use. I found it pretty easy to work with, and depending on what your CLI is for, maybe a simple implementation is the right way to go. There's also one of the things I want to just talk about real quick before, while we're still talking about the CLI frameworks. So there's a number of different tools that make the CLIs easier to work with, or easier for your users to read and interact with. Things that add color, like chalk, and a number of other things that just make it easier to interact with the command line. So be sure to look into those as well. So in our application, in the demo that we're going to be looking at today, one of the first things that we needed to do was be able to store a token somewhere. The way that I implemented that is just by writing that token to a JSON file that's in a hidden directory in the root folder of your computer. It's probably not the most secure. If you're going to be using this for actual production purposes, I would encourage you to look into a solution that's a little bit more secure than that. But it is simple, and it's also nice because it's easy to gain visibility into the tokens that are being generated. One of the things that I found this particularly useful for in the past is generating different tokens and then looking at them just through Vim or whatever text editor and terminal, and then playing around with kind of different token-based error message. What happens when my token has expired? What happens when I have incorrect access scopes? So I found it really useful to store it this way so that I'm able to interact with it and kind of tweak things with what I'm doing. But basically, we're using it's actually the FS extra module rather than just FS, which is built into Node. And that's because it just abstracts some different methods into one for us, which is called this ensure directory. And that just makes sure that this folder actually exists. And if it does not exist, it's going to go ahead and create it. But once that happens, we are actually, yes, okay. So, pardon me, my code's a little funky here. Okay, so basically it's making sure that that is created, and then we are parsing the token. So I see. I clipped a little bit of my code out when I pasted it here, is why I was getting confused. So I have some conditional logic that lives in the actual demo that we're going to go through, and it's based on whether or not this ensure directory encounters a file that actually exists. But basically, once, oh man. Sorry, I think I need to look at this actually in the code, because I deleted some stuff that makes it look very confusing. Okay. Oh, I see. I was just getting my functions mixed up. Okay, so it is very simple. Basically, all we're doing here is I was getting my logic mixed up a little bit here. What we're doing is basically making sure that that directory exists. We are then taking our token that we now have available, our access token, and we are using the JSON stringify to turn it into a string. Then we are taking that string and writing it to this token.json file, which will allow us to bring it in later and do stuff with later. And then we're just using this fsWrite file to actually create the file, and then sending a console log to confirm that we saved the token. So really not that complicated of a function. I just got mixed up because it looks similar to some other logic that we're going to be discussing after this. So it's going to save that token to this JSON file in your root directory, just in this hidden folder. Once we, so one of the things we need our application to do is to use that stored token. If a stored token exists, we don't want to have the user of our CLI have to go through an entire OAuth flow in order to interact with the resources again. Instead, it would be nice if we could just pull in that token that exists and allow them to use the CLI correctly. So the way that we do that is by using fs.readFile, and we tell it what file we're looking for. It's a named variable here, but you can see in the code what that is. But we're essentially saying, read this file and giving it the directory where we saved that token.json. Now, if that comes back as null, or if our token is empty, then we know that we don't have one stored. And we want to kick off a new OAuth flow. So that's what we would be doing in the first half of our conditional. I took that out here. We can look at it in context later. But we're going to assume that we found a token that exists. So first thing we're going to do is we're going to use the json.parse on that file, which will then pull in our string and turn it into JSON format. And in this case, we just have this long-lived token, so it's a little bit more simple of an implementation than other OAuth flows, the one that we're going to go through today. But in the case of your token having multiple parameters, things like a refresh token, an expiry time, that kind of thing, all of that would get stored as a string and then come back and be parsed into JSON, because you may need to interact with different properties within that. But in this case, we're just grabbing that token. Once we have the token, I'm using the Dropbox SDK, which abstracts out kind of a lot of the logic that we would otherwise have here. But basically, we're going to pass in this parse token and say we're going to set the Dropbox client token to that particular token that we grabbed. And then the last step is I'm just doing a simple call to the API to make sure that that token I just brought in that's stored is actually valid. And it's, in this case, I know it's going to be because I just stored that token. But what's significant, what's important about this step and about verifying that that token actually works is the token might not work. It could have expired. It could be malformed. You could have the wrong access scopes to access the resource that you're asking for. And so one of the reasons that it's useful to structure it this way is this catch block can grab all of those error messages for you. If it fails on that API request and you know you have a bad token, you can use that to handle expired tokens. You can use it to handle access scope errors. So it's really useful to structure it this way because then you can grab those other errors when things come back and implement your own custom retry logic for that. So that's how we're using our tokens that are stored. And here comes the lots of code where it's going to be a little bit trickier to get through all of it. Don't worry too much about the implementation right here. We're going to talk through it in context. What we care about here is this is the same little conditional block that we were just looking at here. Is this fs read file when we have a simple conditional inside of it. In the top half, so the part that we're taking out of this code is the logic that we were just looking at for handling a stored token. So if we don't have a stored token, we know we need to get a new one that's up in this top section. That's when we need to actually have a server available to listen for our authorization code that's coming back across. This took me a little while to get right. I tried using Express. And didn't really have much success with that. I know it is possible with Express. Really, any tool that you can use to fire up a server, you can probably bend in ways that makes this use case possible. What ended up working out for me was just using the HTTP library, which is right here, http.createServer. So we have this create server block that's wrapped here, and then we're doing a .listen at the end and giving it a port. So it's going to fire up a server, which then will enter our code block here with our request and response, and then all of this logic will execute in the context of this server being available. So, as I mentioned, it took a little while to get this right, but there are other implementations of other CLIs out there that do something similar. So don't try and reinvent the wheel. If you're really struggling to get the order right, just go peek at other CLIs that exist and see how they structured it. We'll talk through the code in context, so it makes a little bit more sense. But the part that we care about is that we are firing up the server when we run the logic to grab that authorization code. Let me make sure. Yes, OK. One of the things I'm looking at right now is to see whether or not we kicked off our authorization flow before, and it looks like I already did that part. So, OK. Cool. Well, let's look at our application here together. As I mentioned, this is a more simple implementation than some of the other ones that I've done, and that is deliberate. So this is the code that we have been looking at with some nice shiny comments, which aren't really for anyone's benefit since I have not shared this code out. As I mentioned, if you're interested in seeing this particular implementation, feel free to reach out to me on Twitter or somewhere else, and I'd be happy to get it to you, but probably not going to publish it because there's too many things that I would need to do in order to do that. So we have all of these different modules that we're bringing in to provide this functionality. It's pretty typical of a Node application. We're going to be creating our config, which we need to create our Dropbox client right here, which is just how that particular SDK is implemented. This is kind of that Readline scaffolding that we were looking at earlier. You've already seen that. You've already seen this part as well, which is the commands that we're using on Readline, although it's probably a little bit easier to read up here than it was in my slides. We define some very simple commands here. We want to be able to authenticate. We want to be able to delete an existing token. And I threw a couple other things in there just so we could see that it's actually interacting with the API successfully, as well as a command to close the shell. Awesome. So here's some of the other functions that I put in there to interact with the Dropbox API are very simple. One of them just lists the contents of a folder. The other one grabs current account info. My go-to when I'm using an API and trying to verify that a token works is almost always account information, because the payload that comes back is always very predictable. It's always a specific size. You'll have account information that may have that has a variety of information about your account, but it's always consistent. You're always getting back the same thing. When you start interacting with endpoints like list folder contents, you may run into things where things are changing sizes. You don't know how big the payload is going to be. So I always use the account info endpoints to verify that my tokens are working pretty much all across the board. So here is our big one, our get token function, which is called when we run our auth command. And we did look through that a little bit earlier, which is this read file, which is our condition where we determine whether or not we have an existing token. So you understand that we're firing up this HTTP server, that we're creating a server here. And what we did not cover is what's actually happening in here when our code executes. So basically, we're using these different built-in methods to just grab the authorization code off of our query string parameters. And that's all we're doing here is basically just url.parse, and then we're grabbing the query object, and then we're just grabbing a parameter off of that query object, which is our authorization code. You are welcome to parse the URL and grab the information you like however you want. This was preferable to regex for me because everything is preferable to regex for me. And then we are going to do our call to get the actual access token from the Dropbox API. And this is actually abstracted out a little bit more than other implementations that I've done. This does a whole lot of everything for you. So I'm just saying, here's my redirect URL, take it. There's a lot of behind-the-scenes stuff happening here. Nothing too crazy. Just earlier when we were looking at some of the parameters that need to be passed back in order to get your access token, things like grant type equals authorization code and your client ID. Well, actually, we would pass that one back. But Dropbox is doing a lot of that for us with this built-in method. So we're calling out for the token. We're doing it asynchronous, so we make sure that we have that token, and then we're just going to call this setAccessToken method, which is going to take our Dropbox client and apply that token to what's existing in there. As the code continues on and our server is still running, one thing we're going to do is do something with the response. In this case, we're just writing a 302 redirect and passing it to a new location, which is just a GitHub page that I created. You could write your own HTML here and attach it to the response. You can do whatever you'd like. This is just so once the user clicks authorize, it will take them somewhere that it's obvious to them that they have completed an authorization flow. You can structure that however you like. I do recommend you do it. You can get by without doing it, but for an end user, it's going to be confusing for them if they click authorize and nothing happens. But once we've done that and we've grabbed that authorization code, we've used it to generate an access token, we're done with our server. So we can destroy the request, we can close the server, and so we now have our token. And then down here, this is what is actually opening our going to our authorization URL. And actually, that is what I was trying to look at earlier. I would like to speak to how this particular URL makes it into this request to kick that off, but it is eluding me right now. And that is actually one of the things that made it so tricky to build it this way. So it's kind of an important bit I'm leaving out. I'm sorry. But yes. So we have logic for handling a stored token. We have logic for getting a new token. So as far as authorization goes, we're good to go there. We've got our store token function. We know what that does. That's just writing it to a JSON. And then I added a function to delete that token so that we can generate a new one when we want to. So really simple CLI. Really, it only exists to do an OAuth flow, although you could create other use cases for it. Awesome. So if you were using if you were actually creating a CLI that was meant to be used as a CLI, then you would package it a little bit differently, and you would have them either install it, you would probably have them install it as a global node module so that they have access to that CLI. In this case, we're just using that node readline, so we actually need to fire up the shell in order for it to listen for our commands that we're passing in. Let me see what the file's called. OK. So we just execute our script, and now we have our prompt, and we can see that it is waiting for our input to interact with what we're doing. I think I already have a token, but in case we do, I'm just going to go ahead and delete that. So we have gotten rid of our token. Now we don't have one. I'm going to verify that by trying to make a request to the API. And yep, I can't. And it says that the given token is malformed. That's probably because there is no token. Awesome. So we want to have a token. Actually, I need to get to my browser here. So we're going to say auth. It's going to kick off our OAuth flow. And here we're taken to a consent page. I mentioned earlier that the Dropbox implementation of OAuth is different than some of the other ones, so you don't see any access scopes here. And we're going to go ahead and hit continue. Oh, sorry. Actually, this is where the access scopes would live, because this is where it tells the user about the application that you're interacting with. So this is where that would live. But once we click allow, that authorization code is going to get sent back to our server. And here's our authorization page. And this amazing GIF. They saw it over there. Awesome. OK, so we've got an access token that works, theoretically. So now, if I try and call out to the account, we get back an actual response with my account data. Excellent. OK, so we know that the token is working. Just so you have an idea of what that looks like. I can't remember what I called it. Dropbox CLI, that's it. OK, so I'm in my root directory. I've now gone into the hidden folder I created. There's that token.json I created. And this is what I'm talking about. This is what I was talking about earlier. Like, it's very easy to interact with your token that you've stored this way. So it's really, really helpful for testing retry logic around implementing OAuth flows, because you can just gain visibility into the file that you wrote here. You can tweak some things if you want to, for example, the expiry time. Awesome, but there's our token. We know it's working. Let's do one more call, which was just list. Cool. So here's a folder where I have a picture of a fat cat. And let me pull it up. Here it is. Yay. OK, so you can see that it's in there. And that is the same file that we're seeing here. So our OAuth is working. The only other thing that we really have enabled in here is, actually, I know what I'm going to do. I'm going to close this. OK, so now when I fire up the CLI this time, I have a stored token in my JSON file. It is not attached to my Dropbox client yet. So if I try and make an API call, I should be getting another error, even though I have that stored token. So I need to kick off another auth, which in this case is going to just grab the token from that JSON file instead of going through a whole flow. Yep, saved token is valid, saved to Dropbox client. So I know that that token is working. And one of the things that I want to remind you of is that although it was just grabbing that file from the JSON and attaching it to our Dropbox client, inside of that function, we also have a get current account call that is going out to the API. So before it's attaching that to the client, it has verified that it is indeed working the way that we want it to. So that is an important step. Cool. So that I tried to make as simple of a demo as possible. Depending on how much time we have, I have another CLI that I built that's a little bit more complicated, and we can look through that together if you're interested. But that is all that I had for prepared for this talk. The Smartsheet CLI, as I mentioned, is open source and is public. It's a little bit more robust. So if you want to dig into an implementation that does more with an API, that can be a good place to look. But yeah, I'm happy to take any questions before I try and use extra time looking at the other CLI. Yes?
How would you expire a token like that?
What's that?
You said that you can verify your token in your token JSON, or that you could expire it, but how would you expire it?
So the one that we were looking at right there in that JSON file did not have additional parameters such as the expiry date, because it is a long-lived token, because it doesn't expire. if I'm getting an access token from an API that has short-lived access tokens that expire after 7 days, then I'm going to be getting additional parameters back with that token object, which contains whatever date time stamp, and it will expire based on that. What's nice about that as well is when I'm trying to mock out an expired token, I can just go in and change that string of numbers, and then it will behave as if it's expired. But typically, generally speaking, you can't revoke access tokens once they've been issued. You can do that with refresh tokens, but that's not a hard truth. People choose to implement them in different ways. Does anyone have any other questions? There's a lot of information. If you have a need to build a CLI or you want to understand OAuth a little bit deeper, really encourage you to go this route. It's a reasonably simple thing to implement, but goes a really long way in terms of conceptually being able to understand what some of the different pieces are. If there's interest, I'm happy to look at the Smartsheet CLI together for Authenticate. Otherwise, you guys are welcome to have some of the time back. So I'm going to end it now, and then if anyone wants to stick around and look at the CLI, we can. So thank you.